How is everyone? I hope you are fine. Assalamu alaikum. So, if you remember, last time we were talking about diffusion, so we will continue with that. Today we are going to see how many ways there is to find out that particles do exist. That is evidence for particles. So, today we are going to talk about evidence of particles, although we have in the previous class also discussed about it in a way, because diffusion is also just a second. So yes, last time we were discussing it, and if you remember, we were talking about diffusion and spreading out of the ink particles throughout the liquid, and that showed that the ink must be containing some particles which got spread out, and the water must also be containing some particles which got mixed up with the ink particles, and that's why the ink got spread out throughout the liquid. Another experiment that we saw of the same diffusion was about the bromine spreading out throughout the two test tubes when you remove the partition from separating them. Another experiment we saw of diffusion was this of 1 meter tube which was plugged with hydrochloric acid concentrated and concentrated ammonia from the other side, and eventually what happened was this both the particles moved, and wherever they came in contact with each other they underwent a reaction, and ammonium chloride, which is a substance which sublimes, was produced. And as it was produced in the solid state, you will see a kind of slight cloudy area first, and then some particles might stick to the inner surface of the tube, showing that ammonium chloride was produced, and therefore at the point of contact and these particles can be seen as white powder sticking to the inner surface of the tube. Now, evidence of particles is most especially very easy to see when you are talking about when you are talking about balloons. Everyone has a birthday party, and during those birthday parties we inflate a lot of balloons, tie them up and hang them on the walls, right? So these balloons, when they are put up on the wall, they are quite well blown up, right? But as time goes on, they shrink in size. In a day or two, what will happen? The size of the balloon will decrease. This shows that the skin of the balloon must be having some pores or holes, or must be acting like a filter through which these small holes, the inside air is able to escape slowly, very slowly, because this process is so slow that you are unable to see the air leaving the balloon. But over time, over a period of long hours, you will see that the size of the balloon has shrinked, and therefore it is become smaller in size in a day or two. Another experiment you can do very easily is this experiment where you drink a can of Coca-Cola or any soft drink, Pepsi or Mirinda, whatever. What you do is, after that, you seal the top, okay? Or you first fill it up with hot water, then throw that hot water up, and then seal the top using glue gun or any plasticine. It must be properly sealed. There should be any holes. Then you keep this empty can inside the deep freezer. When you keep it in the deep freezer for a few hours, you'll come and open the freezer, and you'll see that the whole can has crumpled up into a small ball or smaller size with no air inside. It is completely crumpled up. Why does it crumble like that? Because the particles of air was there. When you kept it inside the freezer, what happened that the particles cooled and came together. You know that what happens to the particles when they lose their heat energy, they come closer together, trying to change their shape because they lose their vibration of the particles and they come close together. When they do come close together, the inside walls which were exerting pressure outward, now you can see that happening in any polythene bag also. You just keep the inside pressure out, and what will happen, it will have a certain shape, a cylindrical shape. But what happens when you keep it inside the freezer, the particles come together, and the inside particles, as they come together, they exert lesser force on the outer surface and therefore do not push it outward, although the outside pressure is still the same and therefore it is pushing inside inward. तो अंदर ऊपर से प्रेशर बराबर है, लगातार धक्का दे रहा है एयर का पार्टिकल्स, मगर अंदर के पार्टिकल्स have come close together and they are not pushing outward to keep the shape of the can. And so what happens is that the can collapses to that amount of volume which has been decreased is then used in collapsing and making the volume lesser. Another evidence for particle, very interesting one, which is really common and many people were at the beginning surprised as to what is actually happening. When you take a cup of alcohol and you take the same amount of water in another measuring cylinder, take for example 50 ml of alcohol and 50 ml of water, what actually happens is 50 ml, if they are of both the same volume, what will happen is you have 50 ml of alcohol half and 50 ml of water, right? Both are half. When you mix them up together, they should come up to be 100 ml, right? They should fill up to the brim, right? But no, that doesn't happen. It fills up only 80, up to 80 ml. What is actually happening? 50 and 50 should be equal to 100, right? But it doesn't happen. What actually happens? You get 80 ml only. Why? Because the particles of the alcohol fit in between the particles of the water. This is water, H2O, and this is alcohol, C2H5OH. Okay? So when you mix up together, the total volume comes to be lesser. This can easily be seen if you take, instead of water and alcohol, which is in which the particle size cannot be observed, you can take instead peas, 10 ml of peas and 10 ml of rice. When you see the grains of rice, they are smaller. When you see the grains of peas, they are bigger, right? When you mix them up together, what happens is the grains of rice not only fill up the container but also fill in between the spaces that was there in the peas, between the peas particles, which are bigger, so they fit in between, and total volume does not come out to be 20. 10 plus 10 being 20, it comes out less than that. This is actually what happens when you have alcohol and water also. So the total so over here you can see what is actually happening. But what happens when you mix up 50 ml of alcohol and 50 ml of water? You cannot see the particle size, but you know it must be having some particle size. That is exactly why the total volume is coming lesser. आपने तो बराबर लिया है, कम क्यों आ रहा है टोटल? क्योंकि पार्टिकल्स जो हैं फिट कर रहे हैं इन बिटवीन द पार्टिकल्स ऑफ द each other's particle size in between. Okay, so this is the evidence of particles. I hope you understand this much. Okay, a very interesting and quick question. um, okay, if I say that you've got hydrochloric acid over here and you've got ammonia solution over here, and I say that the ring is formed a little bit further away from the hydrochloric side and closer to the ammonia side. So can anybody think and tell me which particles are moving faster and why? That would be an interesting question. Yes?